Hey everybody, this is Mr. Beckstrom, and today we're going to look at solving a system of three equations and three unknowns. And there's either going to be a unique solution, a dependent solution, or no solution at all. So let's see how we're going to do this. When we're dealing with three equations with three unknowns, our strategy and goal is to get two equations with the same two unknowns. So we're going to try to get it down to either two equations with x and y, two equations with x and z, or two equations with y and z. And then we can use our standard method to solve and then finally kind of backtrack to solve the others. So in this case right here, remember we can add, subtract, equations from each other. We can multiply equations by constants, all of that good stuff. So if I start with the first two equations, and let's say I want to get rid of the x, what I can do is I can multiply this equation here by a negative 4. And that will give me a negative 4x, which when I add it to this equation will cancel it out. So that's the first thing I'm going to do. So once I multiply it by a negative 4, I'm going to get a negative 4, and then negative 4 times, negative 4x, and then negative 4 times negative y is just going to be plus 4y, and then finally equals, and then negative 4 times 4 is negative 16. Negative 16 here. All right, so now I have an equation with just the x's and the y's. So I want to get another one with just x's and y's. So how can I do that? Well, if I get rid of the z's through these two equations, then we have to pick different combination of equations to get the second set. So let's say I pick these two, and now what I can do is I can multiply this equation by a positive 5, and that way that will let me cancel out the z's, just leaving me with x's and y's. So let's go ahead and do this. I'm going to kind of write it over here. So this is going to end up being 20y plus 5z. 5z is equal to 60. Is equal to 60. And then I add it to this second equation here. So the second equation is going to be added to this modified first equation. And I'm just going to have a 4x there because there's no other x's. So 4x. All right. And then negative 5z plus positive 5z's. Those are going to cancel out. And then we're just going to have the plus 20y here, plus 20y, because we don't have any y's in that second equation over there. And this is going to be equal to 60 plus 28 is 88. There we go. Now we have two equations with the same two unknowns. So what I can do now is I can add these two equations together. This will cancel out. I'll get 24y is equal to 88 minus 16 is 78, 72. Divide both sides by 24. 24. And we're going to get y is equal to 3. Yay, now I've got the first variable solved. The rest is going to be easy. So notice if I put y back into this first equation, it'll immediately let us solve for x. So pulling that first equation, I'm going to say x minus 3, substituting y for 3, is equal to 4. Therefore, x is equal to 7 when you add 3 to both sides. So that's our second one. And now we can use this second equation or third equation to find the z. So let's use this third equation with the y that we found here. So that one is going to be 4 times, our y is 3, plus z is equal to 12. All right, 4 times 3 is 12. Subtract 12 from both sides, and we're going to end up getting z is equal to 0. And there is our solution. If you have any questions, please let me know, and I hope you have a great rest of your day.